Okay, hello friends, welcome to my lecture. This is Electrical Circuit Lecture 2. Today we are going to discuss about basic laws that are used for electrical circuit analysis. Basically, there are two types of basic laws for analyzing electrical circuit that are Ohm's law and Kirchhoff's law. But today we are going to see what Ohm's law states. Yes, so Ohm's law states that the voltage V across a resistor is directly proportional to what? The current flowing I. Yes, here it is. A voltage, that means a work done just to transfer a unit charge within 1 second. What you call it? Voltage, and a current I. It means that a time rate of change of what? Charge. Here, the main concept here it is a resistance R. Yes, so this resistance R can be defined as the ability to resist a flow of what? Electric current. Yes, so it can be also defined as this an element which is used to limit a flow of electric current. So Ohm's law states that voltage across any element, it is what? Directly proportional to what? A current here. Yes, so mathematically this can be expressed in such a way. So voltage equals what? I, the current, times resistance. Yes, a resistance of what? A resistor. So from this, current can be derived as, if we divide both sides by R, we obtain a formula for I as a function of what? Voltage and resistance. Yes, so V over R. Yes, so this resistance is an element which limit a flow of what? Electric current in a given electrical circuit, and it can be measured as ohm. Yes, so unit of resistance is ohm, and it can be expressed as in such a way. And the other concept here it is what? Conductance. So conductance is symbolized as G, and it can be defined as it is the ability of an element to conduct what? Electric current. Yes, and it is measured in moles. And it can be symbolized as what? It is symbolized as like this, or Siemens. That means S. Yes, we can also define conductance as a reciprocal of what? Resistance. So G can be mathematically defined as, it is what? 1 over R. That means a reciprocal of R. So we can obtain the conductance of a given element just by dividing 1 to its given resistance, and also we can obtain a resistance value of an element just by dividing 1 to its what? Conductance value, that means conductivity. Yes, so here it is how to relate both conductance and resistance. So we can take this as an example. So here it is a simple circuit. This circuit contains three basic elements that are a voltage here, voltage source here, and a wire here. As you see, wire here, wire, and what? It's a resistive element. As you know that a resistance or a resistor is what? A passive element which what? Dissipate a power. Yes. So such element, what we call it? Passive element, and we have an active element here. So a question size, calculate the current I, here it is, and the conductance and the power. So for such type of question, first you have to assign a passive sign convention. Yes. So for a passive element, current must be what? Entering in what? A positive terminal. So this passive element can be, so this passive sign convention can be like this. So as you see, current is entering in a positive terminal for this element. So now let's try to calculate the first one. What is current is? So from Ohm's law, current can be calculated as a voltage across an element over a resistance of what? A resistor. Yes. So a resistance of a resistor for the circuit. It is 5 kilo ohm. So current I can be calculated as a voltage across these resistances. It is 30 volt because, as you see, this terminal, it is parallel with this element, so we can use voltage as 30 volt here, 30 volt over what? 5 kilo ohm. That means we can express as this number as 10 to the power of 3, 5 times 10 to the power of 3. So here it is, 5 times 10 to the power of 3 watt ohm. So we are given in kilo ohm, so we can change it into ohm first. So this can be calculated as 6. Here it is what? 6 times 10 to the power of what? Minus 3 here. Minus 3 ampere. Yes. So we can also express this by using in milliampere. So this can be defined as in milliampere like this. Yes, 6 milliamp. So a current flowing through this circuit is 6 milliampere. And next, conductance. Yes. So as I told you, conductance G can be calculated as what? Dividing 1 by what? Resistance value for a given circuit. So this can be calculated as 1 over, so first it's better to convert this into ohm, so this can be converted as 5 times 10 to the power of 3 because we are given in kilo ohm, so this can be changed as like this. So this can be simplified as 0. What? 2 what? Times 10 raised to minus 3. Yes, so to the power of minus 3 what? The unit of conductance, that is Simon or Mohs, so we can put it like this. So this can be further simplified as what? 0.2 what? So this can be replaced by milli, so we can put like this, milliwatt Mohs or milli Simon. So the conductance for this element is given as, or can be calculated as 0.2 millimos. And the second one is, what is the power? Yes, so as I told you in the previous lecture, power can be obtained as just by multiplying the voltage through a given element by a current flowing through a given element. So this can be calculated. So if we substitute a value of voltage across this element and a value of current that flows through this element, we obtain what? Voltage around this 30 volt. So 30 volt here times, so a current passing through this element is already calculated, that is 6 milliampere or 6 milliamperes here, milliamp. So this can be simplified as 100 what? 80 180 milliwatt. Yes, so a power dissipated on this element can be calculated as 180 milliwatts. So this is the end of my today's lecture. So please try to like, share and subscribe my channel to get more videos. So thank you.